Okay, now we're getting up to the point where we can start getting ready to do the graph. We have one more table to do to get to that point. So let's take a look at that table. So I'll call this table 5. We have two columns that are absorbance values, and then a third column that's also an absorbance. It's called the corrected A sub x. We'll take a look at that. And then we have some calculations we're going to do here. We've already calculated the pH in the previous table. So let's go through this. Really what we're trying to do, there's a derivation that I won't go through, but essentially, if we plot some function of the absorbance values that we measured, as we were adding the acid versus pH, that graph of that will allow us to figure out what the Ka of bromocresol green is. So here's what we're going to do. We're going to start with A2. A2 goes all the way back to the first table. We found out that lambda max was, for this particular experiment here, 615 nanometers. This value, we're going to define A2. Actually, you can see it on the graph here. A2 is the absorbance of the base at its maximum value. So the maximum value was at 615, and that's 0.729. So that would be A2. A1 is the absorbance of the acid form at that same wavelength, 615, and it's 0.004. So those are our A2 and A1, 0.729 and 004. So 0.729, and that's going to be the same every time, and then 0.004. Okay. The next thing we're going to do is we're going to find the corrected AX. Now the AX are these values right here. Oops, sorry. Let's come over here a little bit. Okay, so actually taking a look here, I don't have the AX values at all. You did measure them, but we haven't used them in our calculations. So let's go ahead and put those AX values in. Actually, this is good. So A sub X are the measurements that you actually made. Okay. So I'm just going to make this look a little bit nicer. Okay. So those are for the 4 measurements. So the first one is when you added 2 milliliters. So I'm going to just make up numbers here. Let's say that when we added the first 2 milliliters of acetic acid, the absorbance dropped down at lambda max from 0.729 to 0.502. Okay. Then we added another 2 milliliters and it went down to 0.413. And then we added another 2 milliliters and it went down to 0.341, say. And then we added another 2 milliliters and it went down to 0.302. Okay. Those would be the AX values, the absorbances when you added 2 milliliters. X meaning it's changing, right? So every time we added 2 milliliters, the absorbance changed. Now we're going to do the corrected X. And the way you do corrected X, very simple. What's happening is the absorbance is going down because we're adding the acid, but it's also going down a tiny bit because we're diluting the solution. Every time you add 2 milliliters, it becomes less concentrated. It's not a big change. Going from 100 milliliters to 102 is roughly 2% change. But by the time you get up to 108, now you're close to 8% change. So it is changing a little bit just because of the dilution. So the way we do that is we just multiply by the reverse of what you're adding. If I add 2 milliliters, essentially I say, look, the absorbance would have been bigger without that dilution. So here's how you do it. You hit equal sign. For this one, the total was 102. So I'm going to go put it in parentheses. 102 divided by 100. So that's essentially the dilution ratio. And then I'm going to multiply that by AX. Okay. So what that says is the absorbance would have been a little bit higher, let's say 0.512, if it hadn't been diluted. Now you don't want to autofill here because every time you're doing it, you're adding an extra 2. So for this one, the dilution factor is 104 divided by 100. And then you multiply that by that AX. Okay. And then this one is 106 divided by 100 times AX. And then it's 108. Okay. So 108 over 100 times A sub X. Okay, so now we have our corrected A sub X values. The next thing we do is we're going to take AX minus A1 and then divide that by A2 minus A sub X, okay? All right, so let's go through that. So AX is right here. We're going to use the corrected value minus A1, okay? Close the parentheses, divided by A2 minus A sub X. Close the parentheses. This time, we can actually go ahead and use the fill down because we have all the values that we're using in those particular rows. Now, obviously, these are a lot of sig figs. We don't need to have so many. That's pretty good right there. Now, we're just going to take the log of it. So log of this one. And then we'll fill that down. And again, not so many sig figs required, so we'll make it fewer. Okay. Let's go maybe one more, just a little bit. Now, the pH, we have those from the previous table. Here's our pH. I'm going to copy those. Well, actually, instead of copying those, let's do this a little bit differently. Let's hit equal sign, because again, we may want to go back at some point and change these values if we find that we made an error. So just by hitting equal sign, it's going to actually, it'll change it if I change the value in the previous table. Okay, so there we go. So that's actually the last table that we have to do. The next thing we do is the graphing of this. So I'll do that in the next video.